Okay, so welcome to lecture 8 of this week 9 on the stablecoin project. So we've arrived at the end of discussing the stablecoin dApp basically, and what's left is now the homework. And we would like to use this opportunity to discuss a few points maybe where the current implementation is a bit overly simplified, and yeah, that gives some improvements that could potentially be made by you to maybe practice a bit more with OpShin. And so the limitations, so the first one is kind of now we have seen that the user can lock some collateral. So we have this minting action here where we have seen that the user needs to lock some collateral in the collateral contract. But then once this is locked, it's basically fixed at this amount. And if the user would like to mint more stablecoins, they would ideally maybe not want to create a new UTXO, but just add some ADA to the existing collateral and then be able to mint more stablecoins from that. Yeah, and this just requires some additional action, I suppose, to not only have the mint here, but maybe something that kind of extends an existing position. Next point is that we had this operator in the Oracle parameters. We have like a hard-coded operator. So there's one address which kind of controls the whole thing, but currently there's no incentive actually for this operator to really run the system, let's say, because also updating, so the operator needs to update the collateral every now and then, I don't know, depending on how frequently we expect the price to update. And updating the Oracle also involves spending the current one, so we need to pay some transaction fee. So this actually costs the operator something, but at the same time, there's no fees that kind of go to the operator, so there's no incentive really to do so. And yeah, this is not really sustainable for like practical stablecoins. So the idea would be, can we implement some fee that goes to the operator as an incentive? And then the last limitation I want to briefly touch on here is that in the liquidation case, we saw that basically we can, if we go down here for the liquidate redeemer, we could basically liquidate once this check passes, which is the case once this max mint kind of drops below the amount that is needed for collateralization. And in that case, the liquidator really gets everything in some sense. So it takes the entire over collateralization. So in our example from before, we had collateralization set to 150%, let's say. So if the price only drifts like 1% below the threshold, now the user who put the collateral kind of loses 49% immediately. And this is quite unfair and would basically discourage people to even mint in the first place because of the risk of this loss. So now we get, to summarize again, get to the homework. So I think the first task would be kind of to cap the liquidation reward. So we could simply make the contract enforce that the liquidator gets at most, for example, 2% of the over collateralization. And then the rest of the gap between basically the value and the over collateralization is just sent back to the original collateral owner. So what this would look like is basically that in this case of the liquidate redeemer, then the transaction must now produce two outputs in addition to the burn, and one goes to the liquidator and has this 2%, and one goes back to the original owner. And then the second homework would be related to this operator or developer fee. So the idea is to charge a small fee on every mint, burn, and liquidation, and that one would go to the stablecoin operator. So basically what it would involve is that in every, no matter what is the redeemer in the minting the minting contract, we would kind of assert that there is an additional output paying sort of a certain percentage of the amount being minted or burned or liquidated, and that this right amount of ADA goes to a fee recipient that could be, for example, part of the stablecoin parameters. Okay, so this concludes this week's stablecoin project, and yeah, also because the homework is now a bit more involved maybe than before and actually add some useful features, we would also invite you, if you have implementation of it that you think is correct and you tested it, that you maybe open a pull request actually against the W09 folder of the OpShin Pioneer program with the modified on-chain files and kind of a small paragraph in your PR description explaining how you implemented it and yeah, what choices you made maybe for the reward percentage and the fee rate. Okay, so this wraps up week 9 of the OpShin Pioneer program. And now we only have 1 week left. And in the original Plutus Pioneer program, this last week was used to kind of, in addition to Plutus, give an overview of what other options there are for smart contract languages on Cardano, one of them being OpShin. Since we now discuss OpShin, we want to go kind of the opposite way and use the last week to give just a brief overview of Plutus as well and highlight what are some of the differences and maybe advantages, disadvantages compared to what we have now seen with OpShin. So thanks for watching again and see you in the next week.